Ya, berapa suhunya, berapa ketinggiannya. Kita lihat dulu bagaimana cara menghitung densitas altitude. Ya, tadi pressure, density sekarang.
Density altitude. What causes it? And how does it affect your airplane? Let's jump right in. Heat, humidity, and altitude all lower the air density, and therefore increase density altitude. Heat causes air molecules to have a lot of energy and move farther apart. Water molecules, as in humidity, displace air molecules, and lower atmospheric pressure found at altitude causes air molecules to spread farther apart. All of this has a major impact on how your aircraft performs as the wings, engine, and propeller struggle to grip the thinner air. Dealing with high density altitude.
Ya, jadi makin tinggi, makin berkurang udaranya, makin susah pesawat terbang. Itu harus dipelajari.
Is commonplace for pilots who often fly in hot weather, high humidity, or higher elevations. But for many of us, it can be easily overlooked with profound implications. So pay attention to density altitude, whether reported during flight planning via the ATIS or by ATC, and use your POH and an E6B to calculate density altitude and aircraft performance. Now, what can you do about it? Here are a few tips. Fly light to avoid max gross weight and high density altitude ramifications when dealing with an airplane already performing differently than you're used to.
Ya, tadi dibilangin bahwa karena ada pengaruh ketinggian itu densitasnya berubah. Kembali lagi, tadi pesawat makin tinggi, prestasi terbangnya berubah. Kenapa prestasi terbangnya dirubah? Karena ke densitas udara di atas makin berkurang. Ya. Nah, supaya aman perubahan prestasi terbang tidak berpengaruh begitu banyak, makanya jangan berat-berat. Itu makanya disebutkan di sini, kalau bisa seringan mungkin pesawat itu bawa muatan. Ya, makin berat akan makin berubah itunya prestasi terbangnya.
Determine proper fuel air mixture. If your checklist suggests full rich mixture at sea level, don't assume the same setting at higher density altitudes. Engines differ, so refer to your airplane's POH or the engine's digital monitor or fuel flow gauge manual for optimum power. For a quick and easy method, advance the throttle to take off power during ground run-up and begin reducing or leaning the mixture until the RPM increases and peaks. That's your optimum setting. If you lean beyond this point, the RPM begins to decrease, and eventually the engine will sputter as it is starved for fuel. Similarly, before joining the traffic pattern, determine the best mixture for optimum power during landing or go-around by applying full power, then leaning until RPM peaks. Fly indicated airspeeds. If rotation speed is 55 knots, don't try to rotate at 40 just because you're eating up more runway than usual. Likewise, on landing, the ground and near objects will pass by more quickly. That's correct. Your ground speed is faster for the equivalent airspeed at higher density altitudes when the airplane needs more space to get the required air molecules to fly. Use long runways, but remember the abort point rule. Reach at least 70% of your rotation speed at the runway's midpoint, or abort. For example, a Cessna 172 with a rotation speed of 55 knots departs a 3,000-foot runway. If the airplane's not at 38 knots by 1,500 feet, abort. Watch airspeed and trends and maneuver carefully on climb out and during cruise, as your airplane isn't going to accelerate rapidly nor climb effectively. On takeoff, get airborne and then lower the pitch angle to accelerate in ground effect for the remaining available runway. As you approach the runway end, begin a gradual climb and pitch to climb speed. Chair fly this a few times so you're comfortable with the procedure. Be aware that pitch or bank changes will result in a quicker deceleration than at sea level, as airspeed bleeds off faster at higher density altitudes. Aircraft response to flap retraction, especially early flap retraction, will be more exaggerated than at lower density altitudes. Since the engine is less powerful, you can't regain speed and lift quickly, so monitor POH speeds and positive climb indications carefully. For the same reasons, be extremely attentive to flying into canyons and close to mountains or obstacles, and do not rely on visual cues you normally depend on to clear terrain, because your climb path at higher density altitude is much shallower than expected. Fly early in the day when temperatures are cooler, so performance will be better. We're all well aware that aviation is terribly unforgiving of carelessness or neglect, so let's pay attention to density altitude and its effect on airframe, engine, and propeller performance. Think through your density altitude procedures and never just hope you'll be fine.
Ya, jadi message-nya tadi Anda harus memperhatikan density altitude. Jadi ketinggian, perubahan densitas terhadap ketinggian itu penting karena akan merubah kinerja pesawat. Density altitude sangat penting. Ya. Tadi tips-tipsnya untuk pilot apa yang harus dilakukan. Itu harus dilihat terus ya, density altitude. Sangat besar pengaruhnya terhadap performance. Ini harus selalu dikalkulasi sebelum dia terbang. Ya. Jadi pada ketinggian tertentu densitasnya tentunya berbeda dengan sea level. Nah ini yang namanya standarisasi ya. Kita kan ingin sea level itu ya pressure temperaturnya konstan sebagai pegangan. Sehingga temperatur, pressure, dan densitas di saat-saat lain dibandingkan dengan kondisi standar. Ya. Ini tadi makanya pada saat dingin, pada saat panas, ya dirubah menjadi standar atmosfer. Pasti berubah, ya pasti bergeser dan kita tinggal ngitung yang di standar atmosfer aja. Inilah tabel-tabel, chart-chart yang waktu itu banyak digunakan oleh seorang pilot. Misalkan pada suhu sekian, ya pressure sekian, kita karena ini ya, pada suhu berapa derajat nih? Pada suhu 27 derajat, wah ini pesawat terbang 27 derajat suhunya. Dilihat tekanannya di ketinggian itu. Wah ternyata tekanannya 2000. Berarti kita tarik tekanannya 2000, suhunya 27, tarik ke sini, makanya densitas altitude-nya 4. Oke. Makin tinggi dia, ya, misalkan temperaturnya makin berkurang dia. Berkurang, oh pressure-nya 5000, makanya oh densitasnya 6. Kalau dia makin suhunya makin dingin ke bawah, tapi katakanlah pressure-nya makin kecil karena dia makin tinggi, oh approximate altitude densitasnya nilainya makin rendah. Nah, ini adalah kalkulator lah ya. Ini kalkulator zaman dulu untuk bisa menghitung performance. Zaman sekarang MATLAB, ini yang harus Anda bisa lakukan hari ini. MATLAB ya, untuk bisa mengukur performance. Ya, kembali lagi ini tadi untuk cara-cara menggunakan ini kita gantilah dengan MATLAB ya. Pastikan Anda bisa bikin MATLAB program untuk mengukur density altitude ya, pada saat standar atmosfer atau di luar standar atmosfer.